Well, it wouldn't be Cool Dude Clem's Electronic Workshop if we didn't do some experiments. So I've got this little circuit set up right here. Now I don't know if you can hear that occasional ticking noise that it's making. Maybe if I put the microphone right up close to the relay. Maybe you could hear that. Anyway, this is pretty much, although very crude, a switching regulator. And for those of you interested, here's the schematic of that circuit. Got our voltage supplies here. I'm putting 12 volts in there. I'm putting about 20 volts in there. And you probably can recognize this circuit. It's a basic buck converter circuit. But instead of using a transistor here that's switching in and out a pulsed square wave, I'm basically just using a relay that's switching out that 20 or so volts DC. And to regulate the voltage, we've got our feedback network here, which is going into this op amp, which is set up as a comparator. This is to set the actual voltage output level. That's pretty much it. It turns the relay on when there's not enough voltage here, and turns the relay off when there isn't enough voltage there. It's a very basic and crude, but somewhat functional switching voltage regulator. And this is very similar to how my power supply is going to regulate its voltage. So now let's put a load on this sucker and see what happens. And in this case, I'm using this fan. And there we are. You can probably hear the relay clicking a lot faster now, because it's having to do that a lot more to keep the voltage up. But I can actually adjust the output voltage that this circuit is going to do. So I can have it really high, and that relay is really going like mad now. Or really low. Okay, gonna do a little experiment now. I'm sure some of you might recognize this circuit. We have a bridge rectifier here, a capacitor, and I'm sure most of you know what that circuit does. Anyway, what I'm going to do is I'm going to put mains into this circuit, and we're going to see exactly how safe it is to connect the rectified mains 0 volts to mains ground. There, hopefully that's made it sound a bit more exciting. And I should mention that I don't have this plugged in right now, so there's absolutely no risk of electrocuting myself if I touch anything right now, although that risk will certainly be here in a few minutes. Anyway, I'm just going to connect my meter across the capacitor. Okay, we're at 0 volts. Sometimes there's a little bit of residual voltage in those capacitors, and that's another thing. These capacitors can store their charge for a very long time. You want to make sure to discharge those before handling them. So anyway, I'll go over a brief description of this circuit. The live comes in, goes along this wire, and then goes into this, which is one of my soldering irons. I'm just using that as a safety resistor. Then it goes into the bridge rectifier, charges up this capacitor, and the neutral comes out and goes back into there. And I've got my meter connected across the rectifier, so one wire on the 0 volt side and the other wire on the positive volt side. So I'm now going to plug this in, and you should see the voltage start to rise. Okay, we're at 334 volts. Now you might have noticed that I've got a light bulb here, and that is also connected to the rectified 0 volts. Now I'm going to plug the other end into the earth and see if it lights up. If it lights up, we'll know we've got voltage there. And as you can see, the light bulb does not light up. So that means we've got 0 volts there, right? Well, let's have a look. I'm going to unclip my meter from there. So now I'm going to connect my meter between the 0 volts and the mains earth. And look at that. We have about, don't know if you can see that, we have about 51 volts there. So what is going on? Surely that would have made the light bulb light a little bit. Well, yes, if there was any current behind that, but that's just leakage. There is absolutely bugger all current there. Yes, we might have about 50 volts there, but it's absolutely bugger all current. As a matter of fact, and I strongly suggest that you never ever do this. I can actually touch that 0 volts there and not feel a thing. And just to prove that I'm not lying to you, I will connect the meter up to the diode again. So there we are. We know we have... If I could just do this, because I don't actually want to touch that wire. I'm not going to touch that wire. This is... Okay, that's on there good enough. You can see we have 340 volts. And if I touch this wire, see, I am touching it. I can hold my finger on there, and I don't feel a thing. If there's 50 volts there, surely I should feel something. Well, like I said, it's bugger all current. Now I'm going to connect the other end of the light bulb to the other end of the meter, and I'll plug that into the mains earth. And you can see that there is absolutely 0 volts on the meter there, so I could actually short the mains earth to the 0 volts there, and it would be perfectly safe. So let's do that right now. I'm going to take this out. I'm going to put this into the amps jack, which is pretty much more or less a short circuit. And let's see if we have any current flowing. We might have a couple of milliamps or so. There we are. We've got about 0.007 milliamps. So yeah, it can be done, although probably not recommended. But anyway, when you're done, it's always a good idea to discharge any capacitors.